All right, guys, welcome to class. Let's jump back over to here. All right, so 1 through 10, 11 through 29, odd. All right. Written practice. Use digits and a comparison symbol to write 1 and 3/4 is greater than 1 and 3/5. So 1 and 3/4 is greater than, it always opens to the larger side, than 1 and 3/5. Okay. So 2. Refer to practice problem I above. Use a ruler to find xy to yz. Okay. Interesting. Okay, so I will grab my ruler, which is around here. If you don't have a ruler, that's okay. We can do this a different way, or you can figure that out. So, if we were trying to do this with our metric side, it would be 8.5 from x to z, but that's not what it's asking. It's asking from x to y, which is 5 and 7/10. And then from y to z, it is 2 and 1/6. Now, I assume, though, that it wants this done in inches, because that's what we've been talking about. So I would say that it is 1 and 1/4. 2 and 1/4 for x and y. 2 and 1/4 for x, y. And then from yz, I would say that that is a 1 and 1/16. Okay. All right. 3. What is the quotient when the product of 20 and 20 is divided by this sum of 10 and 10? Okay, product, that means 20 times 20, which is 400. Okay. And sum of 10 and 10, which is 20. We want to know the quotient, so that's the answer. So when 20 divides into 400, and we get 20, 20 is our quotient. Which makes sense, because essentially what you've done is you've done 20 times 20 divided by 20, right? List the single-digit divisors of 1680. Single-digit divisors. Okay, so we're going back a ways in our lessons. So this is greatest common factors. So 1 and 1680. You don't have to have this second part. I just like to have it to know. 1680 is positive, so it can be divided by 2. Okay, and that'll give us 840. The next one, 1680. If you add it up, can it be divided by 3? 8 plus 6 is 14, 1 is 5. So it can be divided by 3. And in fact, if we, this is extra credit here. Uh, 118, 3 goes into 18 6 times, and a 0 at the end, so 560. Okay. If 2, 3 is there, 5 can go into it because it's got a 0 there. 6 can go into it. There's only 1 0 and not 2 zeros, so 4 cannot go into it. 6 can go into it because both 2 and 3 are there. 7, you have to actually do the math. There's no quick here. 2. It looks like it might be able to. 23. So 3 is, sorry, not 3, 4. Sorry, 4. 28, 0, 0 comes down, 0. So 240. So 7 can. 8 cannot. Wait, can 8? It looks like 8 can, actually. Yeah, I think 8 can. Because if we do 1680, that's going to be 2 goes into 16. 8 comes down. That's 1. 8. That 0 goes down. So 210. I thought our rule said that it had to have 3 zeros in order to go through, unless there's another part to it. If the last 3 digits can be divided by 8. Okay. Last 3 digits, 680. Yes, 680 can be divided by 8. Okay. So let's see. We're at 8. Can 9? So we add them all up, and if 9 goes into it, it's good, but it can't. So 9 cannot be divided into it. So 1, 2. Also 4 can. If 8 can go into it, then 4 definitely can. So 4 is actually back on the table. That's my bad. So 1, 2, 3, 4, 5, 6, 7, 8. So everything but 9, as far as I can tell. Because right, 9 requires, if the sum of the digits can be divided by 9, the sum of the digits is 15. 15 cannot be divided by 9. Okay, that was a pain. Point A represents which mixed number on this number line. Okay, so 1, 2, 3, 4, 5. So there's 5 little hash marks, and we're at 3 and 4/5. Replace a circle with a proper thing. So 3 plus 2 equals 2 plus 3. Okay, we have a whole commutative property of addition that says that's true. Oh, geez. This looks like a pain. I really want to put commas here. That's 1, 2, 3 commas. So that is, what, trillion? 1, 2, thousands, millions. What, 3 trillion, 32 trillion? Wow. 32 trillion and 5 million. Okay. And what? That's like America's debt right now. Something like that. All right. It's almost Jeff Bezos' net worth. What fraction of the circle is shaded? That's 3 out of 8, so 3/8 is shaded. What fraction of the circle is not shaded? That's 5/8. What percentage of the rectangle is shaded? Well, there's a total of 1, 2, 3, 4, 5, so 1/5. What percentage is not? That's 4/5. And keep in mind, 3 plus 5 equals 8, 1 plus 4 equals 5, right? Because you have to have a whole in the end. 10. What is the name of the part of a fraction that indicates the number of equal parts in the whole? That is, your divisor, right? Oh, they have a different. The numerator. Or denominator is the. All right. Next page, we're doing. All on the table. This is 11 through 29 odd. 11. A minus $4.70 or equals $2.35. So we have two ways we can do this. We can use our subtraction facts to know that A minus 470 equals 235, A minus 235 equals 470. We can use our addition facts to know that 470 plus 235 equals A, which is helpful. The other option here is using an inverse operations to do the opposite. And what we mean by that is the equal sign is a scale. Okay, as long as that equal sign is there, these parts of the scale are completely equal, and they are absolutely balanced. So if I do something to one side, I have to do the exact same thing to the other for it to remain true. Okay. Now, what that means for us in math is when we're dealing with a mathematical equation, we can do whatever we want to it to try and solve the answer. And so what I mean by that is we can look at this and we can say, okay, A minus 470 equals 235. I'm going to add 470 to both sides of the equation because that will eliminate 470 from this side, the negative 470 from this side, and it will put it on this side. So by adding 470 to both sides, I will end up with A equals 235 plus 470. So that's the same equation as we figured out from our facts. It's just the logic of how we go about it is different. If that makes sense to you, great. If it doesn't make sense to you, that's fine. I just want to show you the adding 470 to both sides is how I learned it, because this crosses out and then this is there, and we're left with A equals 4567.05. Okay. Same deal. It's just a different way of looking at it. 8C equals 60. Okay. In this case, if we were going to do it the way I learned it, we do the same thing to both sides. And what that means is we have 8 times C, so we need to do it inverse, and we need to divide by 8 to cross that out. So now it's just C equals. But we do the same thing to both sides, so we do 60 divided by 8. Now, the way we learned it previously, the way the book talks about it, is it talks about our multiplication and division facts, which say that if you have 8 times C equals 60, you could also rewrite that as C times 8 equals 60, or C equals 60 divided by 8. Okay. 8 goes into 52. I'm sorry, that's not. 7 times, which is 56. 405. So 7.5 or 7.50 is going to be our answer. Okay. So if you had 8 people giving you $7.50, you would end up with $60. E over 15 equals 15. Okay, so what divided by 15 equals 15? Well, we can again use our inverse. E divided by 15, I'm going to instead multiply both sides by 15 to cross out, and I'm going to end up with 15 times 15 over here. Again, if I wanted to, instead of doing this new Mr. Thibodeau way, I wanted to do the way the book teaches. The book teaches our multiplication and division facts, which say that E divided by 15 equals 15, or I could flip them and do E divided by 15 equals 15. That sounded similar. I also know that E equals 15 times 15. either way you look at it. So 15 times 15, or another way to do this is 15 squared, but don't worry about that. 5 times 5 is 25. 5 times 1 is 5. Plus another 5 is 10. Oh, I did that backwards. 25. 5 times 1 is 5, 6, 7, so 75. So 75, and then 0, 5, 1, 5, 2, 2. So 225. So E equals 225. 17. Give a reason for each of the first two steps taken to solve this equation. All right, so it's basically a commutative property as well as our, what is it, formative property, transitive property? What are the two? The first one is, oh man, the names here always get me. Associative property and commutative property. Okay, so first off, they change the parentheses, so that's the associative property. And then it's commutative property of addition for both of those. You're not using the associative property of multiplication, you're using the commutative property, or the associative property of addition, not multiplication. 19, 79 cents times 30. 3 times 9 is 27. 3 times 7 is 21, 23. So $23.70. 21. 6,000 is being divided by 50. Okay, I'll do 50 divided by 6,000. 120. Sorry, my zeros sometimes look like sixes. So 120. 23. 18 divided by 20, or 27 divided by 18. That's what, 5 times? So that is 18 divided by 27 is $1.50. Make sure you have those decimals right. 25. If t is 1,000 and v is 11, find t minus v. So that's 1,000 minus 11. So that would be 989. Or find v minus t, which would be negative 989. 11 minus 100, or 1,000. 27. I have to move this guy so you can see. Compare to see which one is bigger and which one is smaller. So here, for 6 minus 86 plus 119. That's 5, 8, 9, 10. So 205 minus 416 versus 416 minus 86 plus 119. 330 plus 119. Okay, so which one's going to be bigger? Which one's going to be smaller? The interesting thing is these might be pretty similar. So, over here, I have 6 minus 5 is 1. 1 minus 0 is still 1, and 4 minus 2 is 2. So 211 versus over here, I have turn that to a 2, that to a 10, 1, 1, 2, 211. So this one is actually equal on both sides. Okay, and the reason for that is this. If you do 86 plus 119 and then you subtract, or if you subtract first and then add, either way, actually, shouldn't this be smaller? The that's why. Oh, sorry, I got confused here. This is adding 119. They don't equal each other. That should be 9, 4, 4. 449, which is bigger. Sorry, Mr. Thibodeau got confused. It's been a while. I knew something was wrong there. All right, last question, 29. Name a segment parallel to DA. DA. Parallel means they never, ever, ever, ever touch. Well, DC touches, and AB obviously touches. So the only one that doesn't is CB. And next, name a segment perpendicular to DA. That means it forms a right angle. That's one of those squares. That would be DC. I don't know what's going on with that. There you go. All right, guys. That is it. Have a good one.